In this mini lecture, I'm going to cover hypotheses, and we are about ready to discuss the analysis and findings section of your paper, so it's important to review a few of the main components of your research. First, let's review the population, the sample, and participants. The population, this is the larger / whole group from which you sampled. You may have used a method of inviting people to participate in your study using a convenience sample, stratified, or snowball sample, but the sample are those who were invited, those who received your invitation to participate. The participants are those who actually completed the survey. So if you posted on Facebook, on your personal Facebook page, a study that invited social workers to participate in your study, the population would be everybody on your Facebook page. The sample would be the ones who were invited, those who have a social work degree. The participants are the ones who actually took your study and participated. It's important to remember that when you do talk about these in your paper, that you describe them carefully, so that people understand where you started, who had access to the study, who were invited, and who actually completed the surveys. So, although our level of research is not going to include calculating the sampling error, it's important to understand or recognize that it does exist. Sampling error occurs when the measures of distribution, the mean, the mode, the median, for the sample do not match that of the population. So the scores, the mean, the mode, and median on the stress scales or whatever you're handing out, when that measure of distribution do not match the population, then you can say that there's been sampling error. When there is low sampling error and the sample accurately represents the population, then the results of the study may claim to have high generalizability. For example, in our resiliency stress data that we did, almost all the students took the survey. So if we took the results, we did the mean, the mode, the median, we looked at that for the population of the students, and we decided let's randomly select 30% of the population. So 30% of students we're going to randomly select, and we are going to compare their scores to the population, to the whole class. Those scores should be, the mean, the mode, the median should be very, very similar to that of the entire class. So anytime you take a sample out, it should be representative of the whole group. Now let's talk about the null versus the alternative, or the other, just the regular hypothesis. The null is everything is, there's no change, there's nothing going to change. Whatever you did, there's no, your sample is no different than the population. If you gave somebody a treatment, the null says that your treatment, your intervention is not going to work. The alternative hypothesis says that my intervention will work, and so my sample, when I test them after my intervention, will be different than the population. The null says there is not going to be any change in your population. Here is a picture of the histogram that you guys did, so we can kind of get an idea of what the null is and when we can say that there is no change or there is change, and when we can reject the null hypothesis. So if you remember, we created bins for the scores and we created a histogram so we can see where the stress scale is, the Rahe stress scale, where people landed. We have the outlier here at right around 800. And I put these lines in so you can see, because I added our standard deviation. Remember, this is one standard deviation below, and this is one standard deviation above. So here's my one standard deviation below the mean. I didn't put the mean in, but the mean should be like right here in the middle somewhere. So this is one standard deviation below the mean. This is one above the mean. And within here is where 68% of the population scores are. And you can see most of the scores are right in here. Then you have two standard deviations. There's the two standard deviations above and two standard deviations below. And this within that group is where 95% of the scores land. And so you can see, even though this is a skewed bell curve, it still has 95% of all the scores fell within those two standard deviations. And so when we talk about accepting the null and rejecting the null, we want to see that the scores for our study fall outside this. Well, I didn't put in the third. We want to make sure that our scores fall over in this area, then we can reject the null. If our scores fall just like here, we can't say that there was any difference between the population and the sampling, and that our information did not make a difference. We'll go more into the p-values, and the p is 0.05. This second standard deviation is where the p-value falls. So anything over here is statistically significantly different than the rest of the scores. So prior to examining the data, we want to look at three different things. We want to look at the null or the alternative hypothesis. What did we decide on that? What is the null? There is no difference, or whatever we decide. We review the null. We want to talk about or decide on the type of statistical analysis we're going to do. Then what do we do? What does the statistics report? And then we accept or reject the null or answer or the research question. So I'm going to go through these steps one by one. First, let's review the hypothesis. Our descriptive was, we were looking at the categories of data, whether they fell into the 1 to 150 or 151 to 299 categories. Descriptives rarely have a hypothesis. So we're looking at the comparing. So our hypothesis number one is there is no difference in resiliency total between various senior social work students' age groups. So we're going to compare the age groups, and then we're going to talk about the correlation. There is no relationship between the resilience total and the Holmes and Rahi stress care scores for senior social work students. Those were our hypothesis. That's our null hypothesis. There's no difference, there is no difference, and we were hoping to see if there is a difference. So then let's look at the type of statistical analysis that we can do. For the descriptive, we can talk about frequencies and we can talk about percentages. We can also do the mean if you have interval level data, and you can talk about the standard deviations. For comparative, you're going to do a t-test, and you're going to look for a p-level. For the results that we saw, or for a previous year, the p-level was 0.023, which is significant. So we compared different age groups and did the ANOVA, and we did a correlation, which is a Pearson R. And we'll go into a little bit more information about what I meant by all that. So let's look at the descriptive first. Descriptive is categorical data. It is nominal level data. All I can do with this is the data I was looking at, these categories. All I can do is tell you how many people fell into the category of 11 to 150, how many fell into 151 to 299, how many people fell in the category of 300 to 600, and how many fell in the category of 600 plus. So what I can do here, all I can do is tell you the frequency and the percentages. Since this is categorical data, I can't do the mean or the standard deviation. There's no mean for how many people fell into 111 or 11 to 150. So the null hypothesis for the comparative says, there is no difference between resilience total between the various senior social work students' age groups. This is interval level data because the resilience total you can look at the resilience scale, it has an absolute 0. Somebody could have absolutely 0 resilience, and it has up to 800. So it's interval level. We did groups of t-tests. So we did a group of a t-test for those in the 18 to 25. We did a t-test between, so the group, a difference. Let me start over on that, sorry. We broke it into 2 different groups. So one group, we're going to look at utilizing a t-test. So in this case, I used the 18 to 25-year-olds and the 26-year-old as the 2 groups. And then I ran a t-test. In the second inferential statistics that I ran was the ANOVA. It examines how the values in the 3 age groups, 18 to 25, 26 to 35, and 36 plus, compared to one another in terms of the resiliency total. So let's examine how to determine whether we accept or reject the null hypothesis based on the p-value. For most social science students, we utilize the p is 0.05, is less than 0.05, equal to or less than 0.05, to determine if something is statistically significant different. After running the inferential statistics for both the t-test and the ANOVA, it was found that there is no significant difference because this p-value of 0.95 and this p-value of 0.83 is much, much higher than 0.05. We have to accept the null that there's no difference in the there's no difference between the resilience total in the various social work students' age groups. So there's no significant difference in their resilience between the age groups. So then we decided to do a correlation, and we just said there is no relationship between the resilience total and the Holmes and Rahe stress scale scores for senior social work students. So what we're saying basically is that resilience does not affect your stress scores. That's the null. So the resilience total and the Rahe stress scale total are interval level data, and therefore we run inferential statistics. So earlier in the semester, we learned how to run the Pearson R test and evaluate the R squared or the coefficient determinative correlation. For this lecture, let's examine how to determine whether we accept or reject the null hypothesis based on the Pearson R. So after running the inferential statistic, it was found that R equals 0.27. This, again, remember, this is from a previous year, which according to the textbook indicates a weak relationship between the resilience total and the Holmes and Rahe stress scale. Therefore, we will accept the null that reports there is no difference. You're looking at these very, very weak or weak, those two, we have to accept the null. To say that there is a relationship, you would have to have at least a moderate to strong relationship. So if the R value did reveal a moderate, strong, or very strong relationship, then you would reject the null and say that there is a statistically significant difference or statistically significant relationship between resilience and stress scale. So final review for reporting on accepting or rejecting the null. After the hypothesis, accept the null hypothesis if there was no statistical significance. So if p is greater than 0.05 when you run your stats, or if there's a weak relationship in correlations, then there is no statistical significance. And reject the null if there was a statistical significance, significant difference or relationship. So p is 0.05 or less, where there is a strong relationship, strong correlational relationship. Great job sticking with this content. Sometimes it takes a few times of hearing to grasp all the implications, but keep up the great work. We'll talk more about the p-value in future lectures. I just wanted to give you an overview of what the null is and have you kind of get a picture of how where the null is on the bell curve, so you can see if your data falls outside that second standard deviation and becomes a p-value of 0.05 or less.